Today I'll be presenting a use case demonstrating the application of Seeq for truck fleet monitoring. Trucks are a critical asset to any mining operation. They serve to transport minerals and materials from the excavation site to a downstream processing facility, and often this transport occurs under harsh conditions that can negatively impact asset life, requiring frequent maintenance activities. Historically, many companies have used a periodic maintenance approach, scheduling different assets for maintenance arbitrarily based on their position in some rotation. But today, we'll look at an improved approach made possible by Seeq's Workbench Advanced Analytics application. We'll identify which trucks need most urgent maintenance by monitoring for excessive travel time and abnormal profiles of truck telemetry signals that we as subject matter experts know to be common indicators of poor truck health. We'll use logic to ignore excessive travel times due to non-engine issues like mandatory operator breaks, so that we're ensuring only relevant data is used in our analysis. We'll begin our analysis with some critical signals displayed on our screen. These signals were added to the screen from Seeq Data tab by navigating to our mining company asset tree, our truck fleet asset, and then finding the asset we wanted to focus on, in this case, truck 1. We'll look at a single asset for now, and then at the end of the analysis, show how this can quickly be scaled to an entire fleet of truck assets. Once we've got our data loaded on our screen, we'll first attempt to identify each of the truck runs. And by truck runs, we're talking about when the truck is traveling from the base of the mine to the top of the hill. For this, we'll use this altitude signal that you see at the top of the screen. We can use Seeq's value search tool to identify when our altitude signal is greater than a threshold, in this example 5, for some set amount of time. Here, we chose Seeq's options to ignore short capsules and gaps to make sure that we were getting a true detection of a truck travel rather than just little blips of noise in the signal. If we switch into chain view, we can see that the capsules that we've created capture the decrease in altitude at the end that corresponds to the truck returning to the bottom of the mine for the next haul. If we want to get rid of that last little segment of each of those capsules, we do so using Seeq formula, where we can take and we can chop off the last 30 seconds of that capsule to create a capsule that does not include that final drop-off. Once we've honed in on the time periods that we want to focus on during those truck travels, we'll then take and quantify the duration of time spent going from the bottom of the mine to the top of the mine. This was done using Seeq's Signal from Condition tool. Another thing we can do once we've got our time periods that we're wanting to focus on nicely identified is use capsule time view to overlay each truck trip to the top of the mine. From capsule time view, we can take advantage of some other options for our visualization. Right now we're looking at the signals colored the same way they are in the details pane. We can also incorporate coloring by capsule in here to where now each capsule is represented as a unique color on the screen, and we can use our dimming feature to focus in on specific trends if we wanted to. As we're working through this analysis, we can easily switch between the assets that we're looking at using Seeq's asset swapping functionality. By navigating back to that bottom layer of truck assets in the asset tree, I can easily say, swap in truck 3 for all of the items of truck 1 that are on my screen and show me the data for that asset instead. We'll look at truck 3 for the next few steps, as it is a truck that is having frequent maintenance problems. We're now going to use value search and composite condition to focus on the truck travel times where we had excessive travel time. Here, we're defining excessive travel time as the trip taking longer than 45 minutes. When we're looking at our truck travel time signal, we see a few instances of this over here on our screen. We capture that in 2 steps The first using Seeq's value search tool to search against that travel time signal and identify any travel time samples that are greater than 45 minutes. Once we've got those periods identified, they're hard to see on the screen because they're instantaneous events. We can see them in the capsules pane as some of the truck trips from May 7th. Focusing in on our screen, we verify that that looks correct, and then we do the next portion of our analysis, which is capturing the full truck travel whenever it overlaps with one of these excessive travel time capsules. Here, we use our composite condition tool with the touches logic to identify the full travel period when it touches one of our excessive travel times capsules. Identifying an excessive travel time is just one way that we can say that we might be having potential maintenance requirements for a specific truck. Another way is to monitor the different truck telemetry signals using reference profiles. Reference profiles are calculations of statistical limits on a signal based on operation during a period defined as good or ideal. In this example, we'll build a reference profile on the ground speed signal during a period of good operation. From calendar time view, we can see that we've got 3 events that we defined in our previous step as our excessive travel time periods. And these 3 events also don't comply with our reference profile. And if we jump to chain view, we can see this a little bit more easily. We've got a couple of truck travels here where our ground speed signal complies with a very typical profile that we would expect. In our excessive travel times, it looks like the gears that we shift to and the order in which they're shifted does not necessarily follow that same pattern, and so our ground speed is outside of the profile for the duration of that time. We can specifically identify the portions of the travel period where the ground speed signal is outside of the profile using Seeq's Deviation Search tool. Deviation Search allows us to search for when a signal is outside of some variable limits. Here, we're searching for when the ground speed signal is not between our upper and lower standard deviation limit. We've applied a similar concept as we did before, where we're ignoring short capsules and gaps to ignore blips in the process where it went outside the limit and then quickly came back in. If we look at truck 7, we see that there are a few instances of excessive travel time that don't necessarily look like a normal truck trip from the bottom of the mine to the top of the mine. In here, we've got some flatlining events where it appears that there's been a break in the trip. If we want to negate these travels or exclude them from our calculations and our warnings for which trucks need maintenance soon, we can identify these particular truck trips using Seeq formula. We use formula and a combination of different functions to identify the trips that include stoppages. Conceptually, we're looking for any time that the truck altitude signal has a rate of change near 0 during a travel period. In this formula, you can see the different functions that are being applied to do this. Lastly, we'll use formula to find the excessive travel times that have abnormal ground speed profiles but no stoppages. For truck 7, you'll see that there are no predicted engine problem capsules here because each of the abnormal profiles or excessive travel times occurred on one of these travel periods where we had that flatlining altitude, meaning there was a break taken for some reason outside of a maintenance problem. If we look now at truck 3, you'll see that each of these capsules that we identified with excessive travel time is in fact a predicted engine problem. As there are no trip stoppages occurring during this time, it is just a longer version of the trip period profile. When our analysis is completed for a single asset, we can easily scale it out to the entire fleet of truck assets using Seeq's tree map view. I can swap back and forth between trend view and tree map view using my drop-down in the top left of my display pane. From tree map view, I can get a fast overall status of each of the assets in my fleet, where an asset with a tile colored in green means that it is meeting neither the condition for excessive travel time nor predicted engine problems. My tiles shown in yellow have excessive travel times without engine problems, meaning these were the trucks that were taking breaks for whatever reason. Maybe there was a traffic jam in the mine and they are waiting for another truck to pass. My trucks that are shown in red are the trucks that we believe to actually have a maintenance problem coming up soon. From my tree map view, it's interactive and I can click into the tile for any of my different assets to easily see the signals I've got on the screen for that asset. I can then go back to tree map view using my drop down and investigate another asset.